Let's now have something that we can title as haha moment. So let's assume two bodies, and each of them has two frames. Let's write a twist for a frame of green body. Let's assume it will be 3. And we want to increase twist of green body around the pink one, and the motion also, let's assume, that will be expressed in the pink one. So here I put 1 and 1. Okay? So due to our mnemonic rule, I need to put 1 right here and right here, 3 here, and where should I put a dot? The first one. Great. Now let us assume not the frame 3, but the frame 4. So it will be T 4, 1 and 1. So following the same procedure, it will be 1, 4, 4, 1, and with a dot. But we do remember the chain rule. So for the chain rule, it will be like H13 times 3, 4 equal to the H14. Do you agree? So let us put it here. If I'll put it there, I will be left with the H13, H34, so let's put it dot here, plus H13, H34 dot times H41. Do you agree? Yes? So 3 and 4, those frames belong to green body. And if it is a rigid body, the distance between them is constant. It means that the derivative equal to 0. So we need to write H13, H34, H41. And by the chain rule, we know that this thing equal to nothing else as, what should I write? 3, 1. So it will be H13, H31. Does it ring a bell? It means that the twists are the same. It means that you will take any other frame on this red or green body, the result will be the same. It means that the twist will be the constant for all points of this body. And by deriving of this twist, we can talk about absolute motion no matter what kind of frame have we chosen. It's coordinate-free way of describing the motion. And it's actually true because we already discussed it, that in order to talk about those real velocities, we need to know where is the point of something that we want to study. We know this P. And this twist, just like for rotation, angular velocity is the same for any point of a body, right? So if I do the rotation, angular velocity of this link is constant for any of this point. And twist is just like this angular velocity, but it represents general motion. So here you can see the derivation of something that I just gave you. So here it's just another example of our representation. We can do another tricks, and also the result will be the same. It's just another way to tell us that the twist is constant for all frames of the body. So it is in twist and matrix form. Okay, so by far we only talk about velocities, right? Angular velocity and general velocity. But also there is something which is called range, and the range is like the same trick but for the forces and torques. So the range is the bunch of torques and frames and forces. And the funny thing is that if you multiply range and twist, you will get power. And twist is nothing else as a vector of flow, and range is a covector of effort. If we talk about the bone graph of rigid body. And if you do remember, we had a bone graph of Chebyshev lambda mechanism, and it was scary because we used one-dimensional bone graph, but with each bond we can do a multi-dimensional bond, where each effort and flow is not a scalar value but a vector. And this is the way to go. Twist will be a vector, 6 entities, and the range will be a covector or a row or just transpose vector. It also will have 6 entities. And it is the way how can we model multi-body dynamics, because twist will be constant for all points of the body, and range the same. So it will be also constant for all the bodies. And by these structures, we can model rigid body dynamics. But I could explain you the bone graph of a rigid body only when we cover the dynamics part. So here there's several equations. How can we tackle the ranges? So we can also can go from one frame into another frame by using a joint, but transpose a joint. And so let me skip that. If we have like 2 frames, I and J, we can go from one frame into another one, like here, from one frame into another one by using homogeneous transformation matrix. So we need to multiply with the homogeneous transformation matrix, and we will get the same entity but in a different frame. For the twist, in order to go from one frame into another frame, we use a joint. For the ranges, it is transpose and joint. And in bone graph, in order to go from one frame into another frame, we use modulated transformer. Modulated because the coefficient or joint is not a constant, but a function that depends on joint configuration.